Hello, good morning, good afternoon, good evening, wherever you might be. My name is Sean. I'm delighted you're joining us for today's ESBC Community Webinar. Today I'm joined by Thomas MVP and Stephen MVP, who will cover agents, best practices from the trenches. We love hearing you guys have to say, so remember to join on the conversation about today's webinar. Our handle is @ESBC_community and our hashtag is #ESBC25. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated with the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking the Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, Developing Declarative Agents for Microsoft 365 Copilot, with Rick Van Roosevelt, MVP. This webinar will take place Friday, the 11th of April at 11 a.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. Take your Power Platform expertise to new heights at EPPC 25. Join a full-day workshop and master everything from Power Automate to AI agents and Microsoft Copilot. You'll learn from industry professionals and connect with peers who share your passion for innovation. Use code Copilot Week to save €150, but hurry, the offer is only valid until April 30th. Scan the QR code to find out more. At Falcon Europe, you can learn about Power BI, Synapse, Data Factory, Azure, Microsoft Fabric, and more. Book your super early bird tickets today and save up to €700. Book now at www.sharepointeurope.com/European Microsoft Fabric Community Conference tickets. Attend Europe's premier Microsoft 365 and AI conference for incredible insights and real-world inspiration. Book today and take advantage of our super early bird sale. Use the code Copilot Week to save €150. This offer is only valid until April 30th. Scan the QR code to find out more and secure your place. After the webinar, we'll have a questions and answers session. Type any questions you might have in the questions box. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, but you'll be notified by email when it's available. And now I'm going to pass you over to today's webinar presenters, Thomas and Stephen. Thanks for joining us today.
All right, thank you for the intro. Let's start with our session, Agents, Best Practices from the Trenches, basically what we learned. As already mentioned, we are Stefan and Thomas, and to give you a little bit more context, I just took a picture of our office. That's my desk. That desk in the background is Stefan's desk, although today he is in home office. Why did I take the picture? The iPhone camera really didn't catch it, but if you look at a little bit of zooming, you see the mountains in the back of Graz. We are in the south of Austria, so 2 hours south of where EPPC will be in Vienna later this year. And there's still snow up there. It's close to 2,400 meters. And that's the only reason I can come up with why Copilot thinks that agents are such cool objects. Little bad joke, I know, cool and temperature, but that's what Copilot thinks about a Microsoft 365 Copilot agent. Create an image of it, did that I think yesterday or earlier today. And of course, now we all have this image in our heads that agents are basically robots, robotic, autonomous, automation, something like this. We can take the next step and ask Copilot, what are the top 5 reasons to build agents for Microsoft 365 Copilot? We're not going through details, but enhanced efficiency, maybe improved customer engagement as an end result, maybe streamlined processes, okay, customization, flexibility. That's not a reason why I create agent. That's a reason why I maybe choose the platform, okay. Scalability, the same. It's not really a good list, in my opinion, why we should create agents. And my part now is to talk a little bit about 2 high-level concepts, why we think agents are super important. And we want to broaden a bit your view on why agents are important. And Stefan then will take over and go really, really deep on the different options, how to create agents. First thing, why do we need agents? We want consistency. And that's a tough thing if we think about how a large language model actually works. That's a visualization, I think, that should be DeepMind from Google, but doesn't matter. Every large language model nowadays basically is a mixture of different techniques that can be summarized, simplified as a neural network. We have our input signals and we have our different layers in the neural networks, and interference, the way the signal basically takes to the end, to the last layer, is visualized here. The problem that we have with our minds is that, we work with vectors in that space, and our mind, basically our brains, stop at 3 dimensions. If I would say now something like, okay, please imagine a 4th dimension if in your mind as an image, you can try really hard, but your brain is not able to do that. Our imagination stops at 3, and those vectors at large language models have thousands of dimensions. So that's a little bit tough to really visualize. So everything is a model of a model, so simplified, but it helps to see, okay, this runs through. How are those models actually, or with what are they actually working? I'm sure you heard about the term token. And I found a page. You can go there to see the hyperlink down in the bottom and enter a sentence. It breaks it up in different tokens and gives you the probability what the model thinks will be the next token. This homepage, basically pure of performance reasons, uses a GPT-2 model, an older model, a simplified model, so you're not going to get perfect results that you would expect from today's large language models, but it gives you an idea to play with it. Never going to give you up, never going to let you. 78% to 0.85 down, of course. So all a large language model does is basically gives us the next token where it thinks that is the highest probability that you will need that one. You see this through. One important thing, this is an English sentence now with smaller words, and every word basically is broken down, and it gives you the impression that words exactly match tokens. That's not true. Let's try a small German word. It's one word. Donaudampfschifffahrtsgesellschaftskapitän, basically Danube steamship company captain. Yes, German speakers, we know we like to create large words, but you see one word, multiple tokens. So it's not a token, one word, one relationship. It's more detailed, and you see even spaces, question marks, all the kind of things, punctuations are part of tokens. Same thing, I'm just entering this really long word, and then it predicts the next token. You see here, it doesn't predict next word. It's just a token in that case, because German language is a little bit different structured than English. You get not exactly tokens and words in that case, because it already thinks, okay, what would be the next thing? And the gameplay, of course, is to create the longest word, and that's a good starting point, and then you add on and on and on and on. That's how German works, basically. But we can do something different as well. We could question or ask the question from a large language model, where is next year's ESPC conference? And to 28%, it thinks it's in Barcelona. If you look at the history of the conference and the venues, from my memory, we've been to Barcelona, Amsterdam, Copenhagen, and I think in Berlin was the first one, Prague as well. From my knowledge, there wasn't one in Rome, wasn't one in Madrid, wasn't one in Lisbon. Maybe an idea for people, at least the large language model thinks it would be a good idea. Again, take this diagram. Everything a large language model does, prediction of the probability of the next token. Why do we think that still it has so much value using generative AI, using the text? First of all, does your work look like this? Can you reduce the task, the question that you are facing day in, day out to a simple high school math problem where you have a very concrete question? Every term is defined, and there is a if there's not square root, then would be 2 possible answers, mostly 1 exact possible answer. My work doesn't look like this at all. It's all in the gray, all a little bit of this or that, all a question of how do you look at things, what is good, what is bad, today is this, in 3 months the world changed and it's different. So we are in a way of, okay, we are fine with results that are based on a probability. We don't always need deterministic answers. Since the last models are super capable already of doing math in a high level as well, it also can solve those problems. If you look back 18 months, 2 years, those questions already would have been hard for the current large language model back then. What's the other thing? It feels so intelligent. Just if you look at these paragraphs, I asked Copilot to create a couple of lines about agents and how they are created and what agents are on purpose, made it more scientific, and then it starts to really produce scientific English output. Why do we think that this is intelligent? Because if a human would have created these paragraphs, these sentences, and we read it, we think that that human must be intelligent. That's where it comes from. If you are able to write and speak whatever language fluently, sophisticated on a high level, people think you're smart. That's why for us it feels so intelligent. Everything in the background, again, is just the probability token, and we want to create consistency with our agents because we want to have the same input over and over again, and we want to create the probability in a way that we get the same output also. So for the same input, same output. We are not in a deterministic framework. It's not guaranteed that from A always follows B, but with agents and their given prompt, their pre-prepared prompting, we can make it in a way that, okay, we higher the chances that we get the same output or the same output direction day in, day out, and we can rely on that consistency. Another trick you can always do, if it's too complicated, you can use the Feynman technique to explain stuff a little bit easier. Basically, it brings that down to explain it to me as I were 6 or 8 years old. The next thing to consistency that agents help us with is focus. It helps us to focus on a certain task, on a certain skill, on a certain area of knowledge. For example, if I ask my Microsoft 365 Copilot, I want to create a page in a page library. And the scenario I'm painting here is I'm, of course, using PnP PowerShell, the best module out there that you can use in terms of administer or create something in SharePoint. And I have that in my mind that I use PnP PowerShell. I'm not aware of the context. So I just type in, I want to create a page in page library. For me, it's clear I want to use PnP PowerShell. I did not tell that to the system, of course. So it can only answer in a very generic way. Sure, I can help you with that. Are you looking to create a page? Blah, 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 blah. At that point, in the real world, I would be like, wait a second, that's not enough content or not enough context. I need to clarify it more. I need to make it clearer. But what if I ask a special agent for that? Same prompt. I want to create a page in a page library. And this output, let's have a closer look, gives me back add PnP page name, new page name, layout type, article, exactly what I want. Why? Because I created an agent, just a SharePoint agent on top of a PDF. Early this week, I grabbed basically the add area of the documentation of PnP PowerShell, created one large PDF out of it, uploaded it to SharePoint, clicked on create an agent, and went through and configured it, basically this in the backend. That's the agent file. If you download this SharePoint agent file and look at it from a JSON view or with a JSON viewer, then you see, okay, it starts in line 2 to 18 with a little bit of context in sense of conversational starters, welcome message. And then line 19, GPT definition, because agent in SharePoint can be roughly translated to custom GPTs in ChatGPT. What capabilities are we talking about with this agent? It knows about items in SharePoint. It knows about my special PDF. It's the focus. It narrows it down to the focus of this PDF. I try to, not really with a mega instruction. It's just about PnP PowerShell commandlets. But with the focus only on this one piece of knowledge, it gives me way better output compared to just the general question to Copilot. So we have focus on our task at hand. And this is just an example for focus of the type of knowledge. We can think of that of skills to be able to do more, maybe change something in the third-party application, or knowledge in terms of integrating data from a third-party system. But with agents, we want to do two things. We want to deliver consistency. We want to hide the chances that the same input results in the same output. And we want to focus, because that's needed, because otherwise we basically search in the whole wide web. No, we just want to have, in this example, this PDF, and that's a small hint. If you, for example, have a big SAP documentation somewhere, or some PDFs, we call it the Control F use case. People that always know, okay, in that case, I need to open up this PDF document, search for something, and then on page 320, look for a detail, and that's my answer. Upload such PDFs to a SharePoint page, create an agent for that, and your end users will like that because it's way quicker than opening and Control F, and you have your first agent use case basically with, probably 3 lines of text that you need to write your prompt. And with that, I make my life a little bit easier. I say bye, and I hand it over to Stefan.
Perfect. Thank you, Domi. So why is that so important, and why are we talking about agents these days? If you look at what Microsoft announced last Ignite, there was this vision of Copilot basically should be the UI for AI. So that means that you basically, or the end user basically, has a communication set up with Copilot, but Copilot may not be the expert in each and every topic, right? So for that, you basically should go ahead and create agents like Tommy did with his PnP PowerShell agent. That's an expert agent focusing on a specific topic. In that regards, it was PnP PowerShell. And we, like Tommy said, we have that focus, but we also get that consistency. So if you ask the agent, how can I create a page in a page library, it will instruct you on how to do that, no matter how you phrase that question. With Copilot, if you ask Copilot that question, you may get different results based on different context variables and whatnot. So Copilot basically is nothing more than the UI, and the way Copilot works is you can extend it using agents. So you can basically extend the skill set of Copilot. So Copilot comes with a lot of out-of-the-box skills, ranging from features which target the Microsoft 365 apps like Word, Excel, PowerPoint, and Outlook. But it also comes with things like code interpreter, DALL-E image generation, designer, and stuff. And it also can be extended via its knowledge. So out of the box, Microsoft 365 Copilot has access to the Microsoft Graph and also to the web. So it's grounded in the Microsoft Graph, and it may be grounded or it may use grounding in the web for certain prompts. And you can extend both angles. So you can extend the way Microsoft 365 Copilot behaves using skills, and the way what Microsoft Copilot basically knows using both agents. So what is an agent actually? An agent is nothing more than an AI assistant. It's not a new thing, it's not a new concept. We talk about agents for quite a while now. For the last years, we called them chatbots. Nowadays, they're called agents. But when we talk about AI assistants, we basically mean agents. Their goal is basically to help you optimize certain business processes, or from the end user perspective, enhance the end user productivity, all based on large language models and generative AI. And with agents, you can basically pick and choose where you want to publish your agent to within the Microsoft 365 ecosystem, depending on how you're going to build the agent. So you can publish them on their own, so they're standalone agents. You can integrate them into the various Microsoft Copilot products like Microsoft 365 Copilot, even Copilot for sales, service, and finance. And then you have, like Tommy already said, focused agents, like in the Power Platform, you have Power Apps, Copilot agents, and whatnot. How are agents actually integrated into the Microsoft 365 Copilot ecosystem? The heart and soul of M365 Copilot obviously is the orchestrator. So whenever you as the user have access to a set of agents, the orchestrator should make sure that the right agent may be used for the right prompt. As of now, as we know, we need to pick and choose our agent manually. So we need to pick and choose if you want to talk to the P&P PowerShell agent or if you want to talk to the HR agent. In the future, that might change so that you as the end user, your only task is to communicate with M365 Copilot. And as said, that should be the UI, and the orchestrator component in the backend should make sure that the right agent will be picked and will pick up your prompt and then do the reasoning and stuff. But as of now, if you talk to an agent, the first thing which happens is the responsible AI check. If that's passed, the orchestrator does the reasoning. So it basically checks for the intent. It does a tool selection because an agent could have a set of tools or actions as they're called right now. Then it checks the functions which are available and which may be executed along with the parameters which need to be in place for executing a certain function. And if the orchestrator comes to a point where it says, okay, I'm now pretty sure that there's a specific tool the user wants me to execute, the tool execution will take place. In most cases, this will be API based, so there's an API request coming out and as an API response coming back in. And the API response will then basically be analyzed, and the responding action will take place, where in most cases, as we know APIs, we get back a JSON document, and this JSON document may not be one by one forwarded to the end user, but a natural language output may need to be generated. So the orchestrator makes sure that the very technical JSON object will be translated into a more natural output using natural language, and this will be then sent as a response back to the end user. What's important here is whenever you extend the list of Copilot skills using an agent, like I said, API requests may be used. So therefore, Microsoft 365 data could potentially be shared with the external service which hosts the API. So make sure to keep that in mind. When you extend Copilot using a graph connector or an agent which just uses a graph connector, your external data is ingested into the Microsoft Graph, so all the data and information remains within your tenant. So a very important point for you guys to pick up, it's not only about AI these days, it's also quite evenly important to talk about APIs, because APIs fuel agents and they make sure that agents could potentially execute actions, execute tools on the behalf of the end user. So we now know what an agent is, but what specific agent types are there within Microsoft 365 Copilot. There are basically 3 different categories of agents which you can create and build these days. And as I look at the slide, there's a small mistake here because all 3 of them are by this stage generally available. So you have, ranging from simple to advanced, you have retrieval-based agents. Their task is to retrieve information either from grounding data or from reasoning or from any other data source, along with summarizing that data, answer the user's question, and generating content. That's a retrieval-based agent. Quite simple to build, quite simple in handling. Then there's the next category, which is a bit more advanced than a retrieval-based agent, which is the task-based agent. The task-based agent could potentially take actions on your behalf. So a task-based agent could automate workflows or give you the flexibility of handing off repetitive tasks. And an even more advanced scenario or category for an agent is the autonomous agent. The goal of an autonomous agent is to operate independently. So the autonomous agent builds the plan for achieving the goal dynamically. In the future, it might also orchestrate other agents in an agent-to-agent communication setup, and it should learn and escalate independently. So those 3 are the categories of agents you can build these days within the Copilot ecosystem. So an example for a retrieval-based agent might be that the agent automatically reacts to a trigger. So whenever Copilot forwards a prompt of the end user to the agent, that might be the trigger, then the agent has a set of instructions. So the agent knows basically who it is, what its tasks is, what is basically is his or it personality is. So you instruct the agent what to do, and then you also define a plan. So you could say, for instance, the agent might take actions using the tenant data and knowledge, and you provide that knowledge to the agent, and then the agent generates outputs or responses based on the prompts. So in most cases, a retrieval-based agent is there to answer the user's questions. An example for a task-based agent might be that whenever a certain trigger triggers or executes, for instance, when a request comes in from Microsoft Teams, again, the agent has a set of instructions, so it knows what to do and when to do what. And then the plan of the agent could potentially involve to execute certain tasks or execute certain workflows. Like in that case, a Power Automate flow or an HTTP request, or using one of the Power Platform connectors to, for instance, sending out an email based on the behalf of the user. And the outcome, again, might be that the agent then informs the end user, dear end user, I've executed the task on your behalf successfully. This is the output. And an example for an autonomous agent might be that it doesn't need to react directly based on a prompt of the end user, but it might be executed based on a trigger, like when an email arrives in my inbox, or when a SharePoint list item is being created, or when a new opportunity is being created in my CRM system. This is basically using many of the Power Platform connectors and triggers to allow the agent to get triggered autonomously. Then again, the agent lives by its instructions, So use the agent developer or maker. You need to instruct the agent what to do and when to do. So when an email arrives, you tell the agent what to do exactly and build out the plan, like engagement staffing logic, submitting an engagement, then sending out another email, retrieving partner information using Power Automate Flow. And the last thing might be to notify the user who may be concerned about this trigger that the agent has done its routine automatically and autonomously, and so that the user just gets a notification that the agent has successfully executed his plan. And like I said, autonomous agents, they are the most or could be potentially the most advanced scenarios these days when you build agents. And like I said, they're dependent. If you speak about low code to no code, they're dependent on the Power Platform connectors for triggers and for actions. And the cool thing here is you can then basically also use generative AI within the plan. So they could use a large language model to get the input from the trigger, and then within the plan and executing the actions, use generative AI and then generate an output, which then can be sent back to either user or to whatever service which triggered the agent. To summarize, like I said, nowadays you have two options to extend M365 Copilot using agents. Either you extend the skills, so like the actions M365 Copilot can execute on your behalf, or you extend the knowledge with different data sources, maybe also data sources which reside outside of Microsoft 365, like your CRM data, your ERP data, your whatever SaaS platform you're using data. And all of this could potentially be surfaced through a single agent. So you can extend skills and knowledge using a single agent, or depending on your use case, you can also split it up into multiple agents if you like. These days, you have three options of agent types you can create. One of them, Tommy already demonstrated, SharePoint agents. Most simplest form, almost no development effort involved except for the JSON if you want to download it, but it's a real no-code effort to build a SharePoint agent. Then you have declarative agents, which is a more advanced form of a SharePoint agent, because SharePoint agents per definition are also declarative, because you describe what the agent does using instructions and stuff like that. But with declarative agents, you also get the chance of not only extending the knowledge by specifying the SharePoint knowledge sources, you also get the chance of extending the skills. And then you have what's called custom engine agents, where you're not describing what the agent does anymore, but you're building it. No matter if you're building it using Copilot Studio or in a product scenario using, for example, Teams Toolkit, or even more advanced using semantic kernel and whatnot. So you can pick and choose from whatever development environment you like. Like I said, if you're a business user, you might be using SharePoint Online to build SharePoint agents. You might also be using Copilot Agent Builder to build a declarative agent. If you're a maker, a low-code maker, you might be using Copilot Studio to build a declarative agent. And if you're a pro developer, you for sure will be using VS Code, Teams Toolkit, or M365 Agents SDK to build a custom engine agent. And with custom engine agents, you have the full flexibility of using whatever tech choice you might want to use. So you're also not dependent on the M365 Copilot engine. You could use other services as well. So for each and every target audience these days, there's a IDE to build your agent. May that be the agent builder for end users, may that be Copilot Studio for makers, or may that be whatever tech stack for developers in a pro-code scenario. So talking about declarative agents first before we dive deeper into custom engine agents. Declarative agents, and Tommy showed it earlier with his SharePoint example, declarative agents are nothing more than apps for M365 which consist of an app manifest file, a declarative agent manifest, and maybe also an API plugin manifest. So declarative agents basically are nothing more than a manifest file. Within that manifest file, there's a certain section of Copilot agents, and this Copilot agent section basically describes what the agent is and how it behaves. So what is the name of the agent? Like in that case, the agent is called repairs agent. There's a description for the agent, and there are a set of instructions for the agent. The description of the agent is used for the Copilot orchestrator, so it knows what the agent does and when to invoke the agent. And the instructions is then used by the agent itself, so it knows what to do in which case. Like I said, from a no-code, low-code perspective, you have a lot of options to build declarative agents, either using Agent Builder or SharePoint, or going a bit more advanced using Copilot Studio, depending on the skill set you have and what you want to achieve with your agent. So for instance, if you want to surface your agent within SharePoint, the only option you have is using SharePoint and SharePoint agents to do so. If you want to surface your agent within Copilot Chat, you can use either Agent Builder or Copilot Studio. If you want to use or surface your agent outside of Microsoft 365, for instance on a website, you gotta use Copilot Studio to achieve that. And as I said earlier, declarative agents, they are built on top of the Microsoft 365 Copilot platform and architecture. So the Copilot agent architecture consists of foundation models, an orchestrator engine, the user experience, and then a set of knowledge, skills, and autonomy. And with declarative agents, all you basically need to care of is the knowledge, skills, and autonomy part, but you don't need to care about the foundation models, you don't need to care about the orchestrator, and you don't need to care about the user experience. Those three components are provided by Microsoft, and you build on top of them. No matter if you're using a low-code, no-code approach for building your declarative agent, or if you're using a more pro-code approach using Teams Toolkit for Visual Studio Code. In either case, you don't need to care about the foundational models, you don't need to care about the large language model, you don't need to care about how Copilot orchestrates, and you don't need to care about the user experience. That's all being provided for you. All you need to basically do is take care of knowledge and skills. When building declarative agents, like I said, you have two options. Both options result in this nearly same output. Either you go Teams Toolkit for VS Code or Copilot Studio. The declarative agents are built using natural language. So you basically describe what the agent does, give it custom prompt instructions, you define which additional grounding data or focus data should be used for the agent, and then you also define the actions using plugins to define what skill set the agent has. And if you want to know more about building declarative agents, like Sean said earlier, watch out for Rick's webinar tomorrow, where he will for sure be instructing you and showing you how to build declarative agents. In contrast to declarative agents, like I said, there are custom engine agents, and custom engine agents give you more flexibility in terms of how you build your agent. For sure, the effort for building a custom engine agent is in most cases higher than building a declarative agent, but it comes with a lot of more freedom in terms of how you want to build your agent, with which orchestrator you want to build your agent, you can use semantic kernel or Hugging Face or whatever orchestrator you would like to use. And you can also tweak the prompt engineering part. You can use other large language models. You don't need to use the LLMs Copilot uses. You can use, for instance, if you'd like, Claude Sonnet 3.7 or a Llama model or whatever model you would like to use. You can tweak the temperature, max tokens, and all of the other parameters to build basically your custom engine agent. And like I said, it comes with a lot of freedom, but in that case, you also need to provide a lot more components when building your custom engine agent. So you would need to provide, for instance, using the Teams AI library, you would need to provide the foundation model, you would need to take care of the orchestrator, you would need to take care of the autonomy, skills, and knowledge, like I said earlier. And with the Teams AI library, you get a chance of then surfacing your agent using a UX channel which is already known to you, like Microsoft Teams or M365 Copilot. You also have the option of using a rather new SDK, which is the Microsoft 365 Agents SDK. And the Microsoft 365 Agents SDK is the successor of the Bot Framework SDK. And with that, you get even more flexibility in terms of the UX you want to surface your agent in. So you can then build a custom engine agent, which may be used right within Microsoft Teams, right within Microsoft 365 Copilot, alongside Facebook Messenger, for instance, or a web chat scenario. And with that implementation, you can even go as far as building a custom telephony agent, which has a phone number, which you can ring, and the agent then has a voice conversation with the end user on the line. And the good news about custom engine agents is you can even build more sophisticated use cases, like an agent-to-agent scenario, where the end user is talking to an agent. In the past, we called that concierge architecture, where there's an agent, and this agent then orchestrates other agents, and these other agents might be built using semantic kernel or might be built using Copilot Studio. So you have a lot of flexibility. You can choose from a lot of different technology platforms to build your custom agents using the M365 Agents SDK. To sum up this comparison, you build agents on your terms, and you need to decide on if you want to go M365 Copilot based with declarative agents, or if you want to go custom engine. As of now, if you want to build an agent for M365 Copilot or Teams, you can go either declarative or custom engine. But if you want to host and surface your agent on, let's say, a web chat scenario on a web page, you would definitely need to go custom engine. And custom engine means either Copilot Studio in a low-code approach, or Agents SDK, Teams Toolkit, Teams AI library in a pro-code approach. So this is basically the trade-off. Do you want to surface your agent in a channel which is not M365 Copilot, BizChat, or Teams? Then you would need to go custom engine. And like I said, you have the flexibility of choosing between Copilot Studio or a pro-code scenario. So basically, declarative agents, they are built on top of the Microsoft 365 Copilot ecosystem. They're here to extend M365 Copilot, whereas custom engine agents might be completely separated from Copilot, might not be used to extend Copilot, might be surfaced completely in a standalone way. And therefore, you would need to think about a set of questions to answer which Copilot agent option is best suited. First of all, do you want to use the Copilot Orchestrator? If you don't want to use the Copilot Orchestrator, you should be going custom engines all up with whatever tech stack you might want to use. If you want to use the Copilot Orchestrator, then the next question you should ask yourself is, do you want to embed your agent within the M365 Copilot ecosystem? If not, then again, you might be going custom engine with either Copilot Studio if you want to use the Copilot Studio large language model and orchestration mechanism, or if you want to take control of the orchestrator yourself, then you're again at your whatever tech choice you might be using. But if you want to embed it within M365 Copilot, then the last question might be, are you a pro dev or a low-code, no-code maker? If you're a pro dev, you should definitely check out Teams Toolkit for VS Code for building a declarative agent. If you are a low-code maker, you should go either Agent Builder if you're an end user, or Copilot Studio if you are a maker. And with that, I'd say let's take a look at some of the agent scenarios in a demo case. So this is a really basic declarative agent I'm building here using Agent Builder, and all I need to do is basically to instruct the agent what it has to do, what its capabilities are. Like in that case, you're an HR agent designed to assist users with HR related questions. Then the next question would be about the name of my agent. And like you see in that case, the Agent Builder does a really good job in asking me what the shape of and form of my agent should look like, how it should behave, what its name should be, what it should emphasize or focus on, or which topics should be avoided in the agent responses. And this is a more natural way of building my agent, because all I need to do is communicate with Agent Builder in that case via natural language. And if my Agent Builder has finished up building the agent, the next thing I can do right within Agent Builder is test it out. So like you see on the right hand side here, I'm able to use Agent Builder to test it out, as well as I can also then further configure my agent using Agent Builder, browsing for additional grounding knowledge, browsing through my SharePoint pages or sites, where I could then potentially add a set of documents or a complete SharePoint site. Like in my case, I'm referring to a SharePoint site collection, entering the URL here, so my agent knows where to gain information from, which later on will be used as grounding data within the dialogues exchanged between the end user and the agent. And if I finished up building my agent, like I said, I can then integrate my agent, my declarative agent, right within M365 Copilot. So I can then go ahead and surface it either as an immersive experience or in context experience. This is an immersive experience where I have the full or where I only communicate to the HR coach, and this is really like you would communicate with M365 Copilot. You ask it a question, it gives you an answer, you have the references in place. So this is a real simple information retrieval based agent, which I've built here. But like you already may know, I can also use it in context of M365 Copilot using the add mention feature. So I can then add mention my HR coach while talking to M365 Copilot, and it gives me the answer similar to what we've seen earlier. But what I also can do is I can not only build a retrieval-based declarative agent, I can also build a task-based declarative agent. So in that scenario, what I've built is an agent called Taskmaster, and Taskmaster's instruction is to assist the user dealing with personal task management, and it has a skill attached to it, or an action, which is add a to-do in my to-do for business. So whenever a user basically asks this agent to add a new to-do, the agent's task is to create a new to-do in the user's to-do task on behalf of the user. So what I can say is add a new task called whatever title I want to use in whatever to-do list I want to add my to-do task in, and then it will basically use this action on behalf of me, on behalf of my user credentials, and create a task in my to-do list. That's what's capable for declarative agents. If we look at custom engine agents, we can also create retrieval-based agents. Like I've built a retrieval-based HR coach, which is here to answer whatever question I have in terms of HR related topics. So like in my case, what are our health benefits? And it then will reach out to, in my case, SharePoint site collection to retrieve the information for the health benefits from, use the large language model to generate an output, and then send back the output to me. What it will also do is it can also not only generate content for me, but it can also help me and assist me in retrieving information which may reside outside of Microsoft 365, like the question of how many vacation days do I have left. This is currently stored in an HR system. So what the agent will do, whenever I ask it to, it will reach out to the HR system. It will check how many vacation days I have left this year, and then it will come back to me within Teams and tell me I still have 17 vacation days left this year. And if I'm asking for the number of vacation days I've left this year, I might also be interested in requesting a new vacation. And this can also be done using this very agent. So we're then changing from solely retrieval-based to task-based. I can say request a new vacation. The agent knows that I need to input the start and end date. And then if the agent has all of the necessary information, it will basically generate a new vacation approval submission request on behalf of me, and it will deal about all of the approvals necessary to get my vacation request approved. And with that, we are at an autonomous stage, because what happens right now is it will reach out to my manager and ask my manager autonomously to approve or reject my vacation request. And whenever all managers and every involved people have approved, it will then autonomously come back to me as the one who submitted the request, telling me your vacation request has been approved by your manager. Enjoy your time off. And with that, we're at the very end of today's webinar. Like I said, go ahead and watch tomorrow's webinar by Rick on declarative agents and how you build them. And I'm not sure if we have any questions in the chat. If so, we would be happy to answer them.
Yeah, so thank you, Thomas and Stephen, for a great presentation and demos. So now getting into questions and answers part. Should you wish to ask a question, please feel free to type in the questions box now. So the first question is, what security or compliance considerations should teams be aware of when building agents, especially in regulated industries?
like I said earlier, it's if you're building a declarative agent which only uses M365 data, you stay within the M365 security and tenant boundaries. So from a security perspective, you should be good. If you're using an action which uses an external service, it may involve data transmitted to like an external service using an API. So you would need to take that into consideration when building action-based or task-based agents. And also for autonomous agents, the same applies. So you basically would need to think about where is your data, which data sources is your agent working with. If it's inside M365, you should be good. If it's outside, you should take care of the security and regulatory settings.
This, and if I may add, you also need to think about the problem that we call the Google search problem. Your agent, if it reaches out to a third party, is something that users can just talk to in a chat window. It's the same like users can go out there to Google and search for stuff that maybe is confidential. We all know how servers work. If you search for something in a Google search, somewhere in a Google data center, this search query will be stored. So it's the same thing. It's not only about the context that you think, the skill, the task, and that you open potentially up a door where users can, if they just ask for something, or if they do it with a copy and paste error, enter data that can go outside. That's need to be the main question. And then it's a question of risks, risk management. Is this okay for us? Is this not okay for us? What other categories fall in the same block, basically? And as Stefan said, if you reach outside, you need to think about those things. Inside, you are within your Azure tenant and Microsoft 365 tenant boundary, and also within the identity, credentials, permissions of your users.
Perfect. So the next question is, how do you see the role of intelligent agents evolving within Microsoft 365 over the next 12 to 18 months?
That's a bit of a tricky question. Why? Because we went to MVP Summit 2 weeks ago, and we got a little bit of, let's say, a firmware upgrade. So I would like to decline that question. Let me phrase it in a way that you can still make sense of it. Just remember that Microsoft went on stage months ago and said, hey, we know that Copilot needs to be on par with ChatGPT. Otherwise, our customers will ask questions like, why can ChatGPT do this, and why can ChatGPT do that, and Copilot can't do this? So I would look at what ChatGPT allows you to do, and then add one and one together, where the things are heading from a near-term perspective in the sense of, okay, what features can we might expect in the next couple of months? If we think of the next 1 to 2 years, my personal prediction would be that we will start to care less and less about models, because the next iteration or the iteration after the next one will be so capable that we stop caring about which version is this and which version is that, because the basic level is so good already. And we stop about comparing what we get from there, what we get from there. And we will for sure get a complete, and that's already announced and in preview, complete different kind of interaction with Copilot when deep reasoning with researcher hits GA in the next couple of weeks, because then you get like really 10, 15, 20 pages of output based on your tenant data. And that will be the next game changer we see for the foreseeable future.
Perfect. So this next question there is, can I ground my declarative agent with document content retrieved using REST API action in Copilot Studio? I mean not only retrieve some metadata of documents like title, author, but the whole content of the document, which can be retrieved, for example, like base 64 encoded string.
You can use full documents for grounding within declarative agents, yes, not only the metadata.
Perfect. So that looks like all the questions. So on behalf of the ESPC community, we'd like to extend a big thank you to you again, Thomas and Stefan, for taking time out today to carry this webinar. Really appreciate it.
Thanks for having us.
Pleasure.
So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thanks again for all of you for joining us today. I hope you join us again soon. Take care.
See you. Bye.
Bye.